All right, let's talk about this. So you've done, hopefully, you had a chance to work on the 3-6 a little bit, and you've done some things like this. Now, let's go through the steps. When we're trying to write the equation of a line, what form do we want to write the line in? Good, y equals mx plus b, slope-intercept, right? So we want to write it like that, don't we? Okay. What do we need to fill in there to have the equation of the line? Okay, but when in our final answer, it's going to look just like this, only I'm going to have numbers in there instead of what? M and B. I want to fill in the values of M and B, and that's my answer, right? Okay, so to get that though, let's talk about how we get that. We're given M, right? So that part's done. We know what M is. M is 5, but we're missing B. So to find B, what do we do? Okay, we can plug in all the other information that we already know. We know that M is 5, and we can borrow this point. Now, we're going to give it back, because in our final answer, we have to have x's and y's in our answer, right, instead of numbers. Those are variables. But to find B, the fact that we know a point is very useful. We can plug in 3 for y and 2 for x, and if I do that, if I plug in numbers for x and y and m, the only unknown is going to be B, and so I can just solve for it, just isolate B to get the other part of the equation, right? That's it. So let's look at that. So we've just got, if we plug in the stuff that we know, like we said, 3 goes in for y, 5 goes in for m, 2 goes in for x, we just end up with 3 equals 10 plus b, so there's really only one simple step to solve for b, subtract 10, right? If I subtract 10 from both sides, I get b equals -7. And so those are the two ingredients right there. Slope is 5. Whoops. M equals 5 and B equals -7. So all I do then is write the equation in slope-intercept form, adding those numbers, and we're done. That's it. So our answer looks like, I guess it doesn't give us the final. So what's the answer going to look like then if I write it down? Yeah, y equals m, which is 5, x plus -7. How do we write plus -7? -7. So that's what you're going to enter in Moodle. Okay? The equation of the line. Questions? Okay? All right, so the other thing I want to take a quick look at today, and this is really minor, because it's just like 3-6. The only difference is section 3-6 in the book has to do with parallel lines. Section 3-7 has to do with perpendicular lines. That's it. And there's only one difference between the two. We said that the slopes of parallel lines are what? Lines are parallel. What do you know about their slopes? They're the same. Yeah, they're equal, right? Do you remember, going clear back to probably Algebra 1, do you remember what you can say about the slopes of perpendicular lines? So lines that meet at a right angle. Obviously they're not equal. How are they related?
One's negative, one's positive.
Okay, one's negative and one's positive. That's one part of it. There's two differences. They're opposite in sign, so they're opposites.
But they have the same start values.
Well, no, we can't. We're just talking slope now. But what else is different here? They're opposite. If one's negative, one's positive, and vice versa.
They're the same number.
No. They're opposite reciprocals. So that means that we're going to flip the fraction and change the sign. That's it. Another way to think about that is that their slopes have to, or that the product of the slopes has to be -1. But I think that's harder. I think it's easier just to think of them as opposite reciprocals. So for example, if we were to look, let's look at this example right here, where we've got two lines. It looks like, we'll do the red line first. So the red line is this one. The red line, we'll take those points right there and maybe right there. Okay, our goal here is to determine whether the lines are perpendicular. So to do that, all we have to do is just calculate the slopes and see if they're opposite reciprocals. Now there's a bunch of ways we can do this. We can obviously calculate slopes using the points. We could use the slope formula. When you can, if I have a graph available though, I could also use a slope triangle, right? So if I'm gonna do a slope triangle, remember what the rules are for a slope triangle. We always wanna go from left to right when we create the slope triangle, right? So I gotta start here and end up here. Well, what's my rise gonna be? How far? We always wanna do rise first. So I have to go, looks like I have to go down by 2. So what's my rise? It's -2, because I'm going down. And my run? +3, so rise over run then is just -2/3, right? Okay. What about the other line? So the other line will take points maybe like right there and right there. So it looks like to go from left to right, we're gonna have to go up 3, so what's my rise? Good, +3 or just plain old 3. And my run is 2. Good, so we get 3/2. Are those opposite reciprocals? They are, right? Because I flipped the fraction and I changed the sign, right? That's it. So we know that they are perpendicular. Okay, another quick example. Just want to illustrate one little point here. Same kind of thing. Are they perpendicular or not? Well, if we look at the red line, the points that they chose are here, whoops, there, and there. Does it matter which 2 points I choose on a line when I'm calculating the slope?
No.
It really doesn't. I'm gonna get the same slope no matter what. I guess it does only in the sense that you wanna pick convenient points, right? I don't wanna pick points like right there and right there, because they're not intersecting at the corners, and it's hard to make the slope triangle then, right? Okay, but as long as I make them at the corners, it doesn't matter if I use that point, or that point, or that point, or that point as my second point. I'm gonna get the same slope either way. Amazing. Oh, okay, choir people, hit the road. I'm recording this. I'll put it up on the site. I'll do it every day today, I promise, so you keep up, okay? So we make our slope triangle here then. Do you think you'd have more fun singing?
What?
Think you'll have more fun singing?
Totally.
Oh, okay. So what's my rise here? It looks like I'm going up by 6. So I get +6 over +3, right? Rise over run. 6 over 3 is 2. If I calculate the slope of the blue line, looks like we're using points there and there, and I'm gonna go down by 3, so -3 over 1, 2, 3, 4, 5, 6 over +6. So -3/6 is -1/2. Okay, so how could we tell, are those opposite reciprocals? Okay, they are. Now what do I do with this 2? If I wanna find the reciprocal of 2, okay, good, because remember, there's always gonna be an invisible 1 on the bottom whenever you have an integer on the top, positive or negative whole number, right? Do we write it? No, we don't write it. If we want to know what the slope is of the red line, we'd say that the slope is 2. It'd be kind of silly to write the 1 on the bottom, but we know it's there, so if I have to do the reciprocal, the 1 ends up on top, right? 2's on the bottom, change the sign. Okay, very good. Okay, what about this one real quick? Now this one we don't even need the graph. Ignore the graph. This is one where we're given the equations of 2 lines. Let's call this one the red line and this one the blue line. Okay, so I want to know if those 2 lines are perpendicular. Well, just looking at the equation of the red line, do I have to do anything to find the slope? It's given to me. Sean, what's the slope of the red line?
3/4,
Good, how come?
because it has the X.
Good, okay, because the 3/4 is the number in front of x, and it's in the form y equals mx plus b, right? So when we write it in mx plus b form, whatever the coefficient of x is, that's the slope. So we know the slope of the red line is 3/4, and so therefore the slope of the blue line would be what? -4/3. And then we can see right away that 3/4 and -4/3 are opposite reciprocals, and so they are perpendicular. Okay. About one like this real quick. So what if they give you one? There we go. So what if they give you one, that's kind of tricky. What if they give you one like this? Like that. Okay, this is a little bit tougher, right? This time they give us two lines and they're not written in slope-intercept forms, right? And so it's a little harder to see the slope. So if I want to decide, and all I'm trying to do here is decide whether the lines are perpendicular, what do you think I probably should do? To find the slope, what could I do? Yeah, put them in slope-intercept forms. Okay, putting an equation of a line in slope-intercept form is really simple. All that means is solve for y. That's it. We're just going to isolate y. So take line R, the one on the left. What are the two steps in order that we'd have to apply to get y by itself? What do you think? Rylan, what are going to be the two steps in order to get y by itself? First guy. Good, so first we subtract 4x, and then we divide by 5. Good. Okay, and on the right side, line S, we would subtract 5x, divide by 4. Okay, so what's that look like then? If we subtract 4x on this side over here, I get this. Now I'm going to divide everything by 5. But what's it mean, dividing everything by 5? On the left side, I obviously get y. How do I divide two terms by 5? Break them apart. Good, I can just set it up so I can divide each one by 5 individually, so I end up getting something like that, right? So that's kind of a weird way of, I think we could write it better than that. Let me do this real quick. Okay, so if I divide both sides through by 5, I just get that, right? 5's cancel on the left, so I get y equals. Now what about this? If I have negative 4x divided by 5. Good, I could write that, I could split the x out, right? So the x is separate, because multiplying, negative 4x is the same as negative 4 times x, right? And I'm only dividing by 5 once, dividing the whole thing by 5. So I could rewrite that as, whoops, negative 4/5 x plus 2/5, but really who cares? Do we even need to know what the other value is? All we care about is just the slope, right? So really all we need is this. We just need to know that m is negative 4/5, right? Get the idea? So if we go back and do the same thing, and so we end up with this answer. Same thing on the other side. We're going to subtract the 5x, divide by 4, and once again we just end up, oh, what happened here? Oh my gosh, what did I do? Just get rid of that thing. So we end up getting a slope of negative 5/4, right? I don't know why that says 4/5. Hey, listen please. So this is a little messed up. I'll fix the PowerPoint. But this is the slope, and that's the slope. We don't care about the other part, just the slopes. Are those perpendicular? Be careful. They're not. Justin, how come? Okay, because although they're reciprocals, we flipped them. We didn't change the sign. They're both negative, right? So they're actually not. Okay, last example, and then we'll let you work. What about one like this? Okay, so this is similar to the one that we did, similar to the one that we did earlier for the parallel lines. What if we know that one line has the equation y equals negative 2x plus 1, and we want to come up with the equation of a different line that is perpendicular to the first line and passes through the point 4, 0, right? You see that this is almost the same problem we did before. What's going to be the slope of our line if we want it to be perpendicular to this one? Positive 1/2, isn't it? It's got to have an opposite reciprocal slope. So we have to flip the negative 2, which, makes it a negative 1/2, and then we gotta change the sign to positive. So we end up with a slope of 1/2. If the slope is 1/2 and it goes through the point 40, we're gonna do our old trick, right? We're just gonna plug in the x and y values and plug in m so we can solve for b, because that's all we need, right? We already know at this point that m is equal to 1/2. We just need to know what b is, and we plug them in and we're done. So if we do that, if we plug in 4 for x, 0 for y, and 1/2 for m, we get 0 equals 1/2 times 4 plus b. 1/2 times 4 is 2. Subtract 2. b equals -2. Done. That's it. Then y equals mx plus b. m is 1/2, b is -2. That's it. Okay, make sense? All right. That's it. That's the end of the road for us, for this chapter. All right, let's go to find a lab for us here.